welcome to the Fairmont Vancouver. I'm chairing this meeting today. I'm Tim Fitch, President of Invent in Canada. Today we have got a roundtable which is going to be a discussion on all things off-site manufacturing. But first we're going to have a sort of input presentation from Mark Porter from Nexi, who've been very much in the news in the past few weeks, very exciting. Well, I hope we have a great debate. It should be very interesting. I'm looking forward to it. And I'll hand over now to Mark.
All right, thank you. Okay, well, welcome. Thanks for listening to me for the next 10-15 minutes. I'm more interested in the debate afterwards. But just by way of introduction, my background, structural engineer, worked for many years in consulting, and I joined this company called Nexi almost exactly a year ago. Startup company doing off-site manufacture of panels, and invented by two brothers out of Saskatchewan, so mid-Canada. And they came up with a system of creating a structural insulated panel using proprietary polymer concrete on the outside faces rather than OSB or other products. A number of benefits to it, and then kind of joined with an entrepreneur 3 years ago, and we've gone kind of from strength to strength since then. What's really been interesting is the way that we've attracted people to us, and we kind of really focused on why and what is it about Nexi that drives us, and what is it that's our purpose beyond. Buildings construction, number one cause of climate. We're all aware of climate change. Buildings is 39% of that, and many of you in the room are going to know this. I'm not going to dwell on this too much, but these are kind of some of the founding causes of why we think that there was an opportunity for Nexi to come in and disrupt the market potentially with our product. And we're very much focused on our carbon footprint as well. So we've done a lot of research around the embodied carbon in our product, and also the benefit that our product can give to the overall GHG and energy usage in our products. And so just really focused on that, and we continue trying to improve the way that we work with our panelized products. And then cement, concrete is a large emitter of CO2, and so yes, we're using a polymer concrete for its durability, and it's fast cure, and it's got a proprietary mix in it, which means that we can lift it off the casting bed within a matter of hours, which means we can produce a lot of panels, but there's no Portland cement in it, and so we're straight off the top, we're 30% lower, and as I said, we're actively looking at different constituents to put that into context. And then waste is another thing that we're really focused on, is minimizing construction waste on site, so that when we come with our panelized system, we can literally take the waste away with us in one bin load, and really minimize the waste and recycle as much as possible in plant. And then kind of the other focus around solving things for us at Nexi was lack of skilled labor. Continues to be an issue, shortage of labor. Lack of productivity and materials volatility. And just a little aside there, the Nexite is our proprietary material, and we have no issues with material, but we have been affected, even though we like to think we're insular. Steel, plastics, FRP, like the material volatility is really acute right now, and definitely that is a factor. But we can bulk buy, and we can mitigate some of that by pre-purchasing. And then lack of affordability, increased demand in construction, all of those things as a summary really, and sustainability has led to us identifying an opportunity for us at Nexi. And so our solution is panelized solution, prefabricated off-site, a complete envelope system in one panel, substantially less carbon than concrete or steel. We've done some studies on multiple different models, and we've actually got data, and we're building data on every building that we produce, where we're demonstrating that we are both less embodied carbon and less energy usage with our products. Reducing on-site construction, really quiet site, addressing complex code requirements. We have the ability to put fire rating within our panel so that we can do zero dot lines very easily and things like that, so that really helps. And then collapsing all of the trades on site. We're a complete envelope system, and I've got some slides to explain that a little bit more in a bit here. And we collapse the complete envelope system into one panel. Consequently, faster build times, and our products are fire durable, obviously designed for earthquake, wind, and we have no biodegradables in our products, so that makes it very durable from that aspect as well. The verticals that we're looking at right now is multi-story, commercial, residential, high-performance envelope. We have a project in Nanaimo right now where we're doing 9 stories of envelope, high-performance envelope. Commercial retail has been a real niche for us, where we can help our end clients, such as Starbucks, the fast food restaurants, those kind of industries, banks, where they want to build really quickly so they can open their doors really quickly, but at the same time they want to be really environmentally conscious and sustainable, and they've set really aggressive carbon targets. And so we have a product that helps them achieve both those things, a faster build time and a lower footprint and lower energy use. Light industrial, we're looking at some projects there where we're a competitor to Tilt-Up, where there's a need for a higher performance envelope above kind of traditional Tilt-Up, we're a viable alternative to that. And then kind of looking down the road a little bit, we've definitely got our eye on the deep retrofit market. Again, it's kind of an extension to our high-rise envelope panels where we can replace the panels with our product. And single-family residential is on our radar, but we, perhaps unlike different prefabricated manufacturers, we see that as very competitive. We're not volumetric, we're panelized, and we would rather focus our efforts on the first 3 and get ourselves established in those before we focus on a highly customized, highly individual residential market. Or here in Vancouver, where it's wood frame for the mid-rise multi-mixed-use residential. A panel doesn't suit that too well because that's light frame and we've got a concrete-based SIP panel, so we just need to pick what we want. So just some insights to our panel. Some of you, I know, have seen this before, but it's really quite simple, like all the best inventions. We have a proprietary skin on the outside and the inside, and then an EPS Type 2 core. And then we put structure around the perimeter so that we can lift the panels off the bed. The panels come in 10 feet, 12 feet wide, and up to 40 feet long. And depending on the size that we're panelizing, and we need structure to resist wind load, lifting it off the bed, and then if we actually put more structure in, we can actually carry some gravity load, seismic load on it too. The external and internal faces, it's a flowable polymer concrete, so we can actually input a wide range of finishes onto our product, and because it's a very flowable grout, the quality of the finish is really, really good, and we can kind of put brick pattern. We're actually doing a very realistic wood grain pattern. We can tone it, we can paint it, we can do a whole bunch of things on the external surface. It's very hard, very durable, and it comes to site pre-finished, pre-painted, and just touch up at the corners where we connect it. On the inside, again, the panel itself is a drywall type finish, so ready for priming, painting. We can set boxes into the panel, cavities for boxes, cores through the panel, and again, once we finish the space, then it's just finishing up around the joints, making it good, and rather than a kind of a full fit out and finish. Depending on the usage, sometimes we will still fur out the inside. So a little bit more about what the panel is made up of. There's a number of different layers within that panel. Really, really quickly, kind of the outside skin, which is really durable, polymer concrete, and then an insulated core, and then a kind of steel frame or structural core. If we need to put utilities, we'll put that into the CNC machine in the plant, and we'll produce the panels and then This is a section through the panel away. A few things to note here, and I'm just going to stand up so that I can point on the screen. So we have a couple of layers here. We have two types of net type, which is our proprietary polymer concrete. We have an ST, which is structural, a very high compressive strength, very fast cure. And then we have an FS, which is actually got some perlite in it and actually helps us to resist fire. So essentially an inch gives us an hour. And so we can just rate that accordingly. And we just add that where needed, where we need a fire rated wall. That's on the inside. On the outside skin, we have these little channels here. The polymer concrete is effectively impermeable and acts as our rain barrier. But as a kind of a backup to that and allow for any wind-driven rain that happens to get through, we actually put in rounded drainage channels just immediately behind that, and then allow for drips at any joints in the panel. The neck site and the EPS, we don't need any adhesives. The way we cast it, the way we pour it, is that we'll pour the outside with the pattern into a mold, and then we'll put the EPS into that. And as the neck site cures, it kind of forms a covalent bond. It draws itself up into the EPS, and we always get it. Whenever we test it, we always get a shear within the EPS, not the bond layer, which means that we don't have to apply any adhesives, and we can eliminate the VOCs required with that. So we've done a number of tests over the last 2-3 years. The plants are ISO 9001 certified. The panels can function as non-load bearing, or we can do it single story for sure. We can do load bearing. It's resistant to freeze thaw cycles because of the low water absorption. And then we put glass fiber mesh in those skins to help with tension resistance, so that it can bend and flex. And then we use connections at the corners, or in this case, where it's an envelope panel, we'll attach to the floor of this structure and just hang it as we go up the building. At the moment, we're using wet seals, so silicone joints between the panels to seal them. We're actively researching a dry seal alternative for that, because we think that would be faster and actually increase our construction time even more. For the building science people in the room, this really is our air barrier because of the low permeance, and then we have a two-stage sealant on there. And we've had all of this tested. We work very closely with building science consultants such as RDH to have all of this verified, and we're actually currently going through a ICCES testing, which is code equivalency testing in the States, which will recognize our product much more easily than going through an equivalent code equivalency in each jurisdiction. I'm going to flick through these in the interest of time and come on to the Marriott, which is a hotel that's being built in Nanaimo right now. This came to us, it was already designed as a traditional construction, and we did a study on this two or three things. We looked at how fast we could install it, what the improvement over the energy would be, and then kind of how we would fit it and match the branding. On all of those things, we found we could beat the original. We beat the energy performance by around 12%, bearing in mind we just did the envelope, not the whole space. We significantly increased the install time, and we were able to match the branding in terms of the finish to our panels. So we modeled all of that in 3 dimensions, and just quickly kind of give an overview of what we do. We panelize the whole building. We split it into repeatable. The more repeatable panels that we have, the better. And we can deal with insets and outsets and architectural features. But we panelize that building and then work through each panel. It's got a set of shop drawings which is manufactured in the plant. And then this is an image of the finished plant. And so we can put in all of these reveals. We can do the different finishes on the colour. And actually, on this project, we're installing the windows on site and shipping them vertically, so that they'll just go up with the windows pre-installed. That's where we're at right now. The first panels go on in about 2 weeks for us, and so we're hoping to have that done early next year. We're going to be like doing we want to be aiming to get a floor done a week, but we'll see how that progresses as we go through. It's a really tight, constrained site. And then I'll just quickly touch, and this has been a really quick, because I was just told to keep 10 to 15 minutes, just a little bit of a teaser really. Where we're headed. So we have one plant in Swarmish, the founding plant in Moose Jaw, Saskatchewan. If any of you want to go and visit Moose Jaw, it's a great place to go. And then we just about to open Hazleton, which is in Pennsylvania, about 2 hours outside of New York, and we've got a number of projects in New York State that we're looking at. We're in discussions with another plant on Vancouver Island, and certainly there's a couple more there in the States. We're also talking to some in Texas and Florida as well. I think the important thing for us is demonstrating and proving that there's demand to keep the plant full. Once we get going producing panels, they're hungry beasts, and we need to make sure that there's adequate demand. And then this is something that's really come, and you'll have seen this. We achieved something quite remarkable in the last couple of months in terms of our funding. We achieved unicorn status, which means that we've been valued at over $1 billion. I think that's the right number, which is phenomenal for a company that's only 3 years old. A lot of that is to do with the anticipated demand, the interest in the prefabrication, but also our partners that we're partnering with on the technology front. And so we produce the panels, but we've partnered with Honeywell, Train, and a few others we're talking to right now, some other really big names, and we're working with their innovation groups. And Stuart, you know this very well, but they're coming to us and they said, we really like your product, especially for this market where we can deliver a repeatable building that incorporates smart controls, design the system, put it all in skids, make everything modular, manufacturable, deliver the whole thing quickly, effectively, sustainably, and move it to market as fast as we can. So this has been really interesting. We have one particular client right now that has commissioned us to design a bespoke store for them using this methodology, and that's going to be rolled out all across North America. Really exciting for us. It's very small footprint, but it's hugely repeatable, and it gets the volume, and it will be a base load for us in the manufacturing plant. And we see this as a huge opportunity. We do what we do best. We make the panels. We work with them doing what they do best, and we bring it together and package it up and deliver it to site. And I think that is all I have to say. There's lots more that we could talk about, and I look forward to the discussion. But if I can get this to go to the next slide. That is all I have to say.